Good morning. How are you doing today? I believe you are fine. You're welcome to today's class. In our previous class, we discussed on the Earth in space. We explained the rotation and the revolution of the Earth. The Earth rotates on its own axis in an anti-clockwise direction around the Sun, and it takes the Earth 24 hours, which is a day, to complete one rotation. The part of the Earth that faces the Sun experiences the day, while the other part that is far away from the Sun experiences the night. The Earth also moves in a circular path round the Earth, round the Sun, and it takes the Earth to revolve round the Sun. It takes the Earth 365 days to make one revolution. We also discussed the eclipse, and we learned that an eclipse occurs when the moon gets in between the Earth and the Sun, or when the Earth gets in between the moon and the Sun. We have two types of eclipse. We discussed that on the lunar eclipse and the solar eclipse. Solar eclipse occurs when the moon gets in between the Earth and the Sun, thereby blocking the Earth from receiving light from the Sun. And lunar eclipse occurs when the Earth gets in between the moon and the Sun, thereby blocking the moon from receiving light from the Sun. And in this situation, blood moon can occur. I believe you remember that. That was what we learned in the previous class. For today's class, week 10, our topic is satellite. Satellite. You have been getting information in your television. You put on your television. You have your DSTV at home, digital satellite television at home, and you can sit at the comfort of your home. You tune in your television, you tune into the station that you want to watch, probably through the satellite dish. You get news, you get entertainment, and you relax in your home to watch different news, even both local and international news. This is possible because of the satellite. Because of the satellite. Now, let's see our learning objectives before we move on. Satellites is our topic for week 10. Now, let's see the learning objectives. At the end of the lesson, the students should be able to 1. Define satellites. 2. State the types of satellites. 3. Describe the operation of the satellite. And 4. Mention the examples of artificial satellites and their uses. Now, let's see the definition of satellite. A satellite is an object that orbits, that is, moves or revolves around a planet. A satellite is an object that orbits, that moves or revolves around a planet. For example, the Earth is a satellite because it orbits around the Sun. Likewise, the Moon is a satellite because it orbits around the Earth. You can remember in our last class we discussed the revolution and the rotation of the Moon. The Moon revolves around the Earth. So the Moon is a natural satellite of the Earth. So a satellite is an object that orbits around a planet. You can remember the Earth is one of the many planets. So the planet, the satellite of the Earth is the Moon, and also all other 8 planets, they also have their own satellite. They also have moons as their satellites. Now, let me give you This is the picture of satellites orbiting the Earth. You can see these are the satellites. We have like 4 or 5 satellites there moving around the Earth, and these satellites are launched into the space, for different reasons. So as we move on, you see the reason, we'll be discussing the reason why satellites are being launched into the space. Now, let's move on. Types of satellites. We have the natural satellites and we have the artificial satellites. Under the natural satellite is a natural object which revolves around a larger natural object in space. As I've said earlier, the moon is a satellite of the Earth. So the moon is a satellite, is a natural object, and it moves around the Earth. So the Earth here is another larger natural object in the space. So the Earth is larger than the moon. So in natural satellites, they are objects that revolve around another larger object. Example is that the moon is the satellite that revolves around the Earth. I believe you understand that. Now, also we have the artificial satellites. When we say something is artificial, that is, it is man-made. It is man-made. So people build artificial satellites. People build satellites, and it is being launched into the space also to get information on the Earth. Now, artificial satellite is a machine or electronic device that is sent into the space and moves around the Earth and other planets. This artificial satellite is launched into space by the help of spaceship, a rocket. So a rocket will be launched into the space together with the satellite, and at a particular altitude, at a particular distance, the satellite will be released. The rocket will release the satellite to perform its assignment that is being sent to the space for. So artificial satellite is a machine or electronic device that is made by man, and it is sent into the space and moves around the Earth and other planets. So here, as we said, we have 2 types of satellites. The natural satellites, they are natural objects like the moon. It revolves around the Earth and even other planets. And we have the artificial satellite. It's a man-made satellite. It's a machine and electronic device that is sent into the space. It is launched into the space and moves around the Earth and other planets. Now, let's move on. Let's see the reasons of launching a satellite into space. Why do people send satellites into the space? Number 1, for telephone, television, and radio transmission. For telephone, television, and radio transmission. In media industry or in a radio station or television station, satellites are being used to send and receive signal. They are being used to send and receive signal. It can be used to send signal and also receive signal, probably to get information about a particular country, to get the news about a particular country. For example, we have various television stations like the Television Continental, the TVC. We have them here in our environment, and the CNN, Al Jazeera, so they have satellite dish which they use to send information and receive information. As we are in Nigeria now, I can sit down in my home and I tune on my television and I tune into a certain channel, probably like the BBC or CNN, to get information, to get news of what is happening in another country or the international countries. So the help of the satellites help the broadcasting industry to get information. So it is used to send signal and receive signal in television and radio transmission. Also, for photography of a place, town, city, or country, if I want to get the map of a country or the photograph of a particular place in a country, a satellite can be used for that purpose. The satellite can be sent into the space to take the photograph of a particular place, particular town, city, or country. Also, to gather information such as in military to observe the enemy's location and troops. The military satellite is also being used to gather information to observe the enemy's location. This is the enemy's location where the enemies are camping. The satellite can be used to gather information of where the enemies are hiding and their troops also. Also, here, another reason here is to gather information on geographical studies of a country. If I want to get a geographical map of a particular country, probably of Ghana, the satellite can send the satellite into the space to take a geographical map of such a country. And also, the satellite can also be used to locate where natural resources are embedded. Just like crude oil, like gold, silver, iron ore, and so on. So the satellites can be used for this purpose too, to get the location of where natural resources are embedded. I believe you are following me. So these are the reasons of launching a satellite into the space. Now let's move on. The operation of the satellites. How does the satellite work? The satellite works by launching rockets. This rocket, a satellite will be launched together with the rocket. The satellite will be inside the rocket. So the rocket and the satellites, they are being launched into the earth. They are being launched into the space rather. They are being launched into the space of the earth. And it is at a very high speed, at a very high distance, at a very high altitude. So at this altitude, the gravitational force of attraction of this rocket and the satellite will be equal to the force needed to keep the satellite moving freely in the space. And here the satellite moves around the earth at a distance, and the satellite will carry out its assignment. I'll come again here. To launch a satellite into the space, a space vehicle is needed, that is the rocket. So the satellite will be put inside the rocket and the rocket will be launched into the space. Don't forget the satellite is inside the rocket. So the rocket will be launched into the space at a very high altitude, a very high speed, at a distance whereby the Earth's gravitational force of attraction will be equal to the force needed to keep the satellite moving freely in space. So by the time the satellite by the time the rocket has reached the desired altitude, the desired distance, now the rocket will release the satellite. And the gravitational force of attraction of the rocket and the satellite to function in the space will be equal to the force that we need the satellite to keep moving in the space. So the satellite will now move, will orbit around the Earth at this particular distance, and the satellite will carry out its assignments. I believe you understand that. Now let's move on. Let's see the examples of artificial satellites and their uses. Don't forget, I said we have two types of satellites, the natural satellites and the artificial satellites. Yeah, let's see the examples of artificial satellites. Number one, we have the communication satellites. The communication satellite is used to send information, that is signals, very quickly from one place to another. In the broadcasting industry, we use communication satellite to send and receive signal. Use communication satellite to send signal, probably the ones news from an international country, and we are here in Nigeria. So a communication satellite can be sent into the space to receive the signal. They use this to send signal, and also they will receive the signal. So this is why it is possible for us to get international news, to get what is happening all over the world. Also, we have the weather satellites. Here, the meteorologists, that is, they are the scientists that study the weather. So Weather satellite is used by the meteorologists to study weather forecast, to study the weather condition, to study the atmosphere of a place. If you are listening to news, probably during news, during when the newscaster is broadcasting the news, there is a particular section that they will tag this as weather forecast. You see the newscaster will be telling us the temperature, the rainfall, humidity of a particular country. Like now, let's say this is Nigeria. You are listening to NCA news, you see at a particular time after the main news, we hear the weather forecast, the temperature of Lagos State, probably the next day, or the temperature of Kaduna State, the temperature of Oyo State, if it will be likely that rain will fall in Lagos State, in Kaduna State, in Oyo State, the following day we would get this. So this weather satellite helps the meteorologists to study the weather, to study the weather condition. Now we have the observation satellite too. This provides information for geographical studies of the country. Geographical studies such as making map, getting the map of a particular country, and also the location of mineral resources, where mineral resources are embedded. Observation satellites can be used to locate where mineral resources are embedded. Mineral resources like gold, like crude oil, like iron oil, and so on. So observation satellites can be used for this purpose. And lastly, we have reconnaissance satellites. So these are used by the military to locate enemies' camp and troops. They have discussed that in the reason of launching satellites into the space. Reconnaissance satellites is used by the military. So the military will use satellites to locate where their enemy, the country they want to fight against, or if it is any country they want to fight against, or rather they are looking for a criminal. So where this criminal is hiding, the camp, the criminal, and the troops, the condition satellites can be used for this purpose. So we've discussed the examples of artificial satellites. Now I want to share a video with you that discussed the satellites and also the operation of the satellites. So let's see the video now.
Satellite. A satellite is any object that revolves in a curved path around a planet. There are two major types of categorization when it comes down to satellites. One is natural satellite, and the other is artificial satellite. A natural satellite is any celestial body in space that orbits around a larger body. Satellites that are made by people and launched into orbit using rockets are called artificial satellites. Launching an artificial satellite. The launching a satellite into orbit involves two-steps process. First, the satellite has to be taken to the desired altitude. Then, it has to be pushed off at the right velocity to begin and maintain its orbit. To launch a satellite in an orbit around the Earth, launch vehicle, such as a rocket or a space shuttle, is used. A launch vehicle travels straight up only for the first few seconds of its flight. A satellite launch vehicle is a multi-stage rocket. It also contains several smaller booster rockets. The boosters give the rocket its initial thrust during launch and carry the vehicle through the early part of the flight. As the fuel in the boosters is used up, the rocket falls away and the other boosters take over. Each time a booster is dropped, the vehicle gets lighter, so it can travel faster. When it finally reaches the proper altitude and speed, it releases the satellite into the orbit. How a satellite works. Satellite communication consists of three main components: uplink, satellite transponder, downlink. An uplink earth station or other ground equipment transmits the desired signal to the satellite. This satellite transponder amplifies the incoming signal and changes the frequency. This satellite transponder transmits the signal back to downlink earth station, and the ground equipment receives the signal. Satellite communication uses ground stations to send and receive microwave signals between artificial satellites, which are in orbit around the Earth. Types of satellite orbits. By inclination, there are three kinds of satellite orbits: equatorial orbit, inclined orbit, and polar orbit. Equatorial orbit. An equatorial orbit is when the satellite rotates in an orbit directly above the equator, usually in a circular path. It has an inclination of 0 degrees. Inclined orbit. Inclined orbits are virtually all orbits except those that travel directly above the equator or directly above the north and south poles. The angle of inclination vary between 0 to 180 degrees. Polar orbit. A polar orbit is when the satellite rotates in a path that takes it over the north and south poles in an orbital pattern that is perpendicular to the equatorial plane. Polar orbiting satellites follow a low-altitude path close to Earth's surface, passing over and very close to both the north and south poles. The angle of inclination of a satellite in a polar orbit is nearly 90 degrees. On the basis of the altitude from Earth, the types of orbits are classified into low Earth orbit, medium Earth orbit, and geostationary Earth orbit. Low Earth orbit. Low Earth orbit satellites operate at a distance of about 160 to 2,000 kilometers above the Earth's surface. It takes approximately 90 to 120 minutes to circle the Earth. Medium Earth orbit. medium Earth orbit is the region of space around the Earth above low Earth orbit and below geostationary orbit. The orbital periods of medium Earth orbit satellites range from about 2 to 6 hours. This satellite operates at altitudes between 2,000 kilometers and 35,786 kilometers above the Earth's surface. Geostationary Earth orbit. A geostationary satellite is an Earth-orbiting satellite. It placed at an altitude of approximately 35,786 kilometers directly over the equator, that revolves in the same direction the Earth rotates, that means west to east. This satellite takes 24 hours to orbit the Earth. Orbits are also classified into two types on the basis of the shape: circular orbit and elliptical orbit. Circular orbit. Circular orbit is the orbit with a fixed distance around the barycenter, that is, in the shape of a circle. This orbit has an eccentricity of 0. There are several types of circular orbits, and they include geostationary orbit, polar orbit, and equatorial orbit. Elliptical orbit. An elliptical orbit is the revolving of one object around another in an oval-shaped path called an ellipse. The eccentricity of an elliptical orbit is greater than 0 but less than 1. Sometimes these satellites are closer, and at other times they are farther away from Earth. The closest point a satellite comes to Earth is called its perigee. The farthest point is the apogee. The most common example of elliptical orbit is highly elliptical orbit. Types of artificial satellites. Navigation satellite. A satellite navigation system used to determine the ground position of an object. It determines the geographic location of ships, aircrafts, or any other object. It is also vital to military forces. It is often used for gathering intelligence used for military purposes or as a military weapon. The major satellite navigation systems. The navigation satellite system with global coverage is called Global Navigation Satellite System, or GNSS. The United States was the first country to introduce satellite technology with the Global Positioning System, or GPS. Another ambitious global navigation satellite system aside from GPS in development is the Galileo system in Europe. Russia also has its own satellite system, called the Russian Global Navigation Satellite System, or GLONASS. In China, there is the Beidou Navigation Satellite System, which will consist of more than 30 satellites. There is the Indian Regional Navigation Satellite System, or IRNSS, in India. Lastly, the Quasi-Zenith Satellite System, or QZSS, is Japan's satellite system, which is similar to a GPS satellites with some slight variations. Weather satellite. Weather satellites are primarily used to monitor the weather and climate of the Earth, to predict daily weather conditions, such as temperature and rainfall, to monitor how weather conditions, like storms, hurricanes, cyclone, tropical storms, develop and change over time. Communication satellite. The communication satellite is a satellite that transmits the signals such as telephone, television, radio, internet signals over long distances. If you do like my channel, please subscribe, comment, share the videos to your friends and like.
So I believe this video has been able to enhance your understanding on the operation of the satellites, and I believe you enjoyed it also and learned something new. Now, let's continue. So, as I've seen in the video, we've seen the type of artificial satellites, also the examples of artificial satellites, and even the countries that have been able to make the satellite system. Good. Now, with this, we've come to the end of the class. But before we conclude, let's do the summary of what we've learned so far. We've learned about satellites. I'm saying satellites, they are objects that orbit around the planet. We also discussed the types of satellites, natural satellites and the artificial satellites. Natural satellites are natural objects that orbit around another natural object. An example is that the moon is a satellite of the Earth. Under the artificial satellites, we said that artificial satellites are satellites that are made by man, and their machines and their electronic devices are launched into the space for specific purposes. Also, we discussed the reason of launching satellites into the space to transmit and receive signal in the television industry, that is the broadcasting industry, or to gather information about the weather, to get the enemy's camp and troops, and also for communication, to get the location of natural resources. Also, we discuss the examples of natural satellites, the communication satellites, the weather satellites, the observation satellites, and we have the reconnaissance satellites. I believe you enjoyed the class. Now, let's see the references. The video is gotten from the internet, that is the YouTube, and this is the link of the video. Reference it, how satellites work, the animation of how satellites work. The video I played for you is gotten from the YouTube, the Connected School, the YouTube. And also you can move back to the textbook based on for junior secondary school, and the Spectrum Basic Science for junior secondary school. You can read more on the topic satellites from these textbooks, and also the video that I played for you, how satellites was gotten from YouTube, and this is the link. Reference is also from the Connected School. You can watch it and watch it over again to get more knowledge on this particular topic. Thank you. With this, we've come to the end of the class. Please ensure that you do your assignments and you read the notes. Continue to stay safe and stay blessed. Bye.